Okay, so um, here we go. Solve and check and graph the following equation. So you have to be careful here because um, you have to represent the answer in the graph as well. Okay, so we'll take care of that. And it's so let me change colors. Okay, so I like to do this line. Okay, splitting my equation to two sides, the left side and the right side. I'm going to do the inverse of subtraction, which is addition. So plus 12 and plus 12 on the other side. This minus 12 and the plus 12 becomes 0, so I don't need to write 0, so I just have m left over. Equals 33 plus 12, let's see, is 45. I check the original equation, m minus 12, 33, so I'm going to, I'll write it down, n minus 12 is 33. I'm going to replace my m with 45. Minus 12 equals 33. Oops. It's 33. Is 45 minus 12 33? Yes, it is. And that equals 33 on the other side. That's what an equation is. Two expressions that equal each other. Okay. So, and in order for that to be equal, I needed m to be 45. So my graph here, okay, I just plot a couple of points, 45, 46 on this 7, 46, 44. And the only number that satisfies this or makes this equation true is 45. So I'm going to put a circle on top for 5 and shade it. I'm not pointing an arrow to the left. I'm not pointing an arrow to the right because that would mean that numbers on this side would make this equation true, but they not. So the only thing that makes this equation true is the number 45, and that's why it's a shaded circle. Here, okay, so it's an addition equation here. I'm going to split this in half again. I'm going to get rid of this constant, not 77. Okay, I want to isolate my variable. I want to have y all by itself here, so I'm going to go minus 63, minus 63. And if I do that, this 63 and this 63 will disappear because they equal to 0. The y will come down. And on this side, 77 minus 63 is 414. So let's see if that's true. I'm going to copy the original equation. 63 plus y equals 77. 63 plus 14 equals 77. And you'll notice that 63 plus 14 is indeed 77. And 77 is 77 on the other side. Okay, again, my number line. 14, right? 14, 15, just a couple of numbers, one on each side, 13. Circle on top of the 14, and that's the only number that makes this equation true. Okay. Next one. This is a multiplication equation. Okay, so something's being multiplied to a variable to equal 36. So to find the value of that variable, I'm going to use inverse operations. I'm going to divide this by 4. I divide this by 4. If I divide 4 by 4, I'm left with 1. And I bring down the k, or just 1k. And remember I told you I don't need to write 1k. I'll just write k. Same thing. And 36 divided by 4 is just simply 9. Okay, so copy the original equation. 4 times k equals 36. Let's replace k with 9. 4 times 9 is 36. Is that true? Yes, it is. 36 on this side equals 36 on that side. So, number line again. 9, 10, and 8 on this side. Circle on top of the 9. Let's shade that. So 9 makes this equation true. This one is a division, right? H divided by a number I don't know, represented by h divided by 4 equals 64. So let's find what that number is. So I'm going to actually copy that over here. H equals over 64 equals 64. So it's division, so I'm going to multiply both sides by something. Multiply both sides by this 4 over here. Multiply this by 4. So this 4 and this 4 becomes 1, leaving me with 1h, or just simply h. And on this side, I'm multiplying 64 divided by 4, which is 256. So h divided by 4 equals 64, or 256 divided by 4 equals 64. Is that true? Let's see. 64 goes into 25. 6 times, yeah, 1 left over, and bring down the 6, 4 goes to 16 4 times, so it is 64 equals 64. Okay. Here is an example where the coefficient is a fraction. So an easy way to get rid of that fraction is to multiply both sides by the reciprocal. I'm going to multiply 3/4 over here by 4/3. I'll multiply this side by 4/3. This will all equal to 1, which will leave me as 1w. Oops, I forgot to draw that line over here. So everything's going to disappear because it's just going to be 1 and 1w, or just w. On this side, I'm going to multiply, so I'm going to put this 15 over 1. Okay, now that's a fraction times a fraction, numerator times numerator. 15 times 4 is 60. And 1 times 3 at the bottom is 3. And that's 60 over 3, which is the same thing as 20. So, no, that's not it. That's not true, is it? 4 times 5 is 20 equals 6. Yep, yeah, that's right. Okay, so the original equation is 3/4 of w. I'm going to replace it by 20 equals 15. So if you had $20 and I took 3/4 of it, would that be 15? Yeah, it'd be. Okay, because 20 divided by 4 will be into 4 parts of 5, and if I had 3 parts of 5, 3 would give you 15. So let's see. If I multiply 3 times 20 is 60. 4 times, let me put 1 over here. 4 times 1 is 1, and 60 over 4 is indeed 15, which equals 15 on the other side. Number line. The number that makes this equation true is w when w equals 20. So 20, 21, 19. I'll put a circle on top of that 20. Shade it. Okay. Is m equals 5 a solution to the equation? Well, the only thing the only thing you can do to see if it really is a solution is substitute. So wherever you see the m, I'm going to replace it with 5. So that becomes 2 times 5 plus 12 equals 34. 2 times 5 is 10. Then I'm going to add it to 12 equals 34. Doesn't look like it. 10 plus 12 is 22. And that's definitely not equal to 34. So m equals 5. It's not a solution to this particular equation. Okay, so the answer is no. Okay, because I just proved it to you. Okay. Still raining. Write an inequality for each statement. Graph and find 3 possible solutions. Okay. To pass the test, students must earn a grade of 75 and above. So let's use T. And I'm going to go 75. So your test score has to be what in order for you to pass? It has to be 75 and above. So it could be greater than 75, and it can also equal to 75. 3 possible solutions that will make this inequality true will be 76, because if I substitute 76 over here, it will be greater than 75. Another number would be 85. It would also make this inequality true. I can pick even 75. If I put 75 over here, it's not going to be greater than 75, but it's going to be equal to 75. So these 3 are possible solutions to this inequality. Okay, but nothing under, obviously, 75. To fight in the middleweight division, fighters must be under 160 pounds. I think this is wrong. I think you have to be a little bit heavier, because 160 pounds looks a little bit too light for a middleweight division. So, but nevertheless, let's assume that's true. So, in order for you to fight in the middleweight division, okay, so for fighters, what do you have to be compared to 160? You have to be under 160, so you have to be less. So your waiter as a fighter, your weight as a fighter has to be what compared to 160? Less than 160. Possible solutions? Well, if you're 160, would you be in the middleweight category here? Let's see if I put 160 over here. Would that be less than 160? No, so 160 is not a possible solution. So 159 would work. Anything under 158, 157, you don't want to be 130 and fight the middleweight division. Okay, you'd be too skinny actually. Okay. The most you should spend on the gift is 75. So let's say you're doing like a Secret Santa, and with your friends, and you want to set a limit. In this case, the limit is up to 75. Okay. So here's G for gift. Here's 75. So whatever you buy here can be less than 75 or equal to 75. Possible solutions, well, Can you spend $60? Yes, you can, because that would be less than 75. Can you spend, I don't know, $42? Yes, you can, because that would be okay. Can you even spend 75? That would also be okay. All right. You will get a speeding ticket if your speed is greater than 65 miles an hour. Yep. So S for speed and 65. In order for you to get the speeding ticket, what does your speed have to be? Has to be greater than 65. Can it be 65? What if you're exactly 65? Is it greater than 65? No, so this is not a possible solution. So we're looking at numbers greater than 65. So 66, you better get a ticket. Not too expensive, but 80, definitely get a ticket. And 100 miles. So those are three possible solutions for that. So translate the following sentences to equations. Okay, so now it's the same thing like when we translated expressions. Just do it right under it. Okay, like step by step. A number, let's call it K, decrease by means subtraction, decrease by 8 equals 12. Ta-da! Not that difficult. 11. 9 less a number equals 15. 9 less a number equals 15. Now, less a number is not a turnaround word. Less than a number, yes, but not less. Just less by itself, it's not. Okay. 50 is equal to K multiplied by 8. 17 increased by 18 is 93. What? Okay, so definitely a mistake over there. Okay, I probably meant to say 17 increased by a variable. So let's just make that an m or something. Okay, definitely didn't mean to say 17 plus 18 equals 93 because that's not true. So probably meant to say that 18 was supposed to be a variable. Okay, so as it is incorrect. Now this is the one that's really a pain. Let's see if I can get it right this time. So write an equation to represent the scenarios. Make sure to set up the equation where the variable is not by itself. So you don't want the variable isolated. Okay, not that it's wrong, but because if you get a multiple choice where you don't see it set up that way, I like you to be able to recognize it. Okay, so Kathy scored 10 more points than Nancy. Kathy scored 34 points. So, two numbers. What equals 34? 34 is what Kathy scored. Right? So Kathy scored 30 points. What can equal 34? Well, the one thing that can equal 34 is what Nancy did, right? Plus 10 points. So Nancy, who scored a little lower, we'll call it N, whatever her score is, was a little lower than Kathy. So, but I know that if I add Nancy plus 10, that will equal to Kathy on the other side. Okay, so there is your equation. Where your variable is not isolated. Okay, that doesn't say N equals 34 minus 10. It's just it's actually an equation where you can solve using inverse operation. Okay. Sandra earned 32 less than Tom. Tom earned 55. So let's write Tom over here. Represents $55. Is there anything that equals to 55? Well, whatever Sandra earned, which is very little, much less than Tom, whatever she earned, well, represented by S, plus 32 will give you Tom. So if you actually solve this, and let's solve this just so that we can see if it works. Minus 32 here, minus 32 here. If you subtract, these 32 become 0. You're left with S. And Sandra made how much? Earned how much? 5 minus 2 is 3. 5 minus 23. So does that make sense? Sandra earned $23. Is that 32 less dollars than Tom at 55? Yes, it is. Okay. So over here, let's actually solve this. So this would be minus 10, minus 10. The plus 10 and minus 10 equals 0. So you're left with n, and 34 minus 10 is 24. So does that make sense that Nancy scored 24 points? Yes, because how much did Kathy score? 10 more points. So there you go. Okay, the way we set up actually gets us to the answer. Okay. The area of a small apartment is 150 meters squared. The length is 10. So what is the width? Okay, so we did something like this today, but where we were given the base and the height or the length and the width, but this is a little bit different. So let's write the equation. The area. Okay, so apparently the apartment is a rectangle, right? So the length is 10 meters, and we're looking for the width. So I don't know how much the width is, but I know that if I multiply length times width, it says that I get 150. So the area, okay, the area is 150, the length is 10 meters, and I don't know what the width is. So what times 10 will give you 150? Okay, what does the width have to be? What can I multiply 10 by to give me 150? So we can use, here you're free to use whatever you want. They're not telling you to inverse operation. I will. This says 10 times w, so I'm going to use the opposite of multiplication, which is division. And this is going to be divided by 10. And I'm going to divide that side by 10, right? So this 10 and this 10 will equal to 1, right? 10 divided by 10 is 1. I'm going to have w left over. So w is 150 over 10, or I'm sorry, I should have said just w equals 15, because 150 divided by 10 is 15. So the length, I'm sorry, the width of this small apartment is 15. Does that make sense? Let's see. To find the area of this rectangle, I do length times width, 10 times 15, and 10 times 15 is indeed 150 meters squared. That's a big apartment, okay? Okay, so inside, remember we talked about today, inside this apartment, you would have squares, big squares, much bigger than the ones I showed you, where every side is 1 meter. So a meter is the height from the floor to about your waist, or about the doorknob, okay? So imagine a square that has a side of 1 meter, okay, on all 4 sides. Okay, so imagine 150 of them next to each other. Okay, 150, obviously, this picture's not, imagine 150 of this next to each other, all right? And that would give you the size of the apartment. And that's what 150 meters squared means, okay? 150 of those squares side by side to shape the apartment. Okay, so in this case, it's almost like a little backwards. They gave you the area, and you're trying to find one of the pieces that multiplied gave you 150. Write an equation from the table shown and fill the missing values. Okay, I think everybody had a good time with this one because this, it's pretty. So it's times 21. Well, times 21. Is this times 21 as well? Yes, it is. So this one is going to be times 21. So 4 times 1 is 8. 4 times 2 is 8, 88. No, 4 times 1 is 4. Oh my God. 4, 84. All right, so what's the equation? Well, I can say the total, okay, the total money, the total cost. And I'm not going to write that. I'm just going to represent it. So the total cost of whatever I'm spending is going to be the books, right? Times what? Each book is times 21. So 21 times B. And there's my equation. Okay, to find the cost, the total, I multiply the number of books times 21. This one, 5 to 60, 7 to 84, 9 times 12. Times 12, times 12, times 12. This is going to be times 12, which is going to give me 132. Okay, so it looks like 132. So the equation, my total wages, the total wages depends on the hours. Good, so the total wages here depends on the hours. So it's going to be H. And what are we multiplying H by? Every single hour here, 5 hours, 7 hours, 9 hours, 11 hours, be multiplied by 12. And that's my equation, W equals 12H. Boo, boo, boo. Games, cost. Okay, this one's easy. Look at the 10, don't look at the other ones, look at this one first because that's easy to figure out. It's times 15. Just make sure that everything else is also times 15. Just because it works for one, it doesn't mean it's going to work for all the ones. So make sure your rule works for most, not most, all of them actually. So times 15, my 45, it works. So, and here it's going to be times 15. 6 times 5 is 30. Goes 390, so that would be 90. Okay. So the equation, the total cost that you spend at GameStop or wherever you're shopping for your games is going to be dependent on your games, G. And each game is going to be multiplied by 15. Okay, 15G. This one in the equation XY, so Y equals whatever. So 2 times 13. What? No. 2 times 7 minus 1. 6 times 7. No, that doesn't work. 2 times 5 minus 2. That also doesn't work. 10. Let's say 10 times 5, which is 55. 6 times 5. 2 times 5. 2 times, no. 7. 2 times 8. 2 times something. What the heck? It's 2 times 7 is 14. Minus 1. Okay, 6 times 7 is 14. That doesn't work. 10 times 5. 6 times 5 is 30. No, 10 times 1 minus 6. 10 times 6 times 6. How about times 6? 36 minus 3 times 6. No, it doesn't work. Times 6. Okay, I have no idea. I could actually. Did I make a mistake here? Probably looks like that. So I don't. 6 times. What's the plus? How about times 5 plus 3? Oh, thank you. So all right, I think I got it. I think it's times 5 plus 3. So every x is going to be multiplied times 5, and then you're going to add 3. Let's see if that works. 2 times 5 is 10 plus 3, 13. Good. 6 times 5 is 30 plus 3, 13, 33. Good. 10 times 5 is 50 plus 3, 53. So that's the rule. So 8 times 5 is 40 plus 3, 43. Jeez. Identify the independent and dependent variables. Stan is going to buy apples. They cost $1.25 each. So what's your independent? What's your dependent variable here? My independent is going to be my apples. My dependent is going to be the total I spend on apples. Okay, so the total I spend depends on what? On the apples. Okay, my total money, the total cost, whatever you want to call it. Okay, that's your dependent. Rob is going bowling. Shoe rentals are $6 and cost $4.50 per game. So the total. So remember the sentence. The total blank depends on this. So the total cost. Okay, depends on what? Depends on the game. Okay, so my independent and my dependent. My dependent is the total cost. My independent is the game. So that's going to be what my, the more games I play, the more I pay. The less the less I play. Okay, that's my independent. That's what's changing. The shoe rent was just $6 for the whole evening. Okay, I think, unless they raise the prices. And wow, that's it really? 2 more. Table below shows a relationship between hours and miles driven. Write an equation to describe the relationship between hours and miles. Graph. Graph was 2 H's. Yay. Okay, so there's no H. Complete the sentence. This depends on this. So what depends on what? The total hours depends on the miles, or the miles depends on the hours. And in this case, the total miles, or the miles, depends on the hours driven, right? So we're going to use, I would use M. M equals H, right? And what's the relationship here? Times 5 times 5 times 5. Yeah, it's times 5. So to find the distance you travel at any point, you got to do 5 times H. So however many hours, just multiply by 5. So I'm just making stuff. Let's say you drove for 20 hours. So if you drove for 20 hours, how many miles do you drive? Well, 5 times 20 gives you 100. Right, so this is the rule that you're going to use over and over again to find the total number of miles. Okay, let's graph this. I don't know why I just did that, but okay, so M equals 5H. Remember, your independent's going to go down here. Your dependent goes over here. Your title, miles driven, and the hours. So it's going here, and then I'm going to write hours here. I'm going to fit 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to do 1 box each. 1, 2, 3. Oops, not there. Even worse. 2, 3, 4, 5, 6, 7, 8. I know we don't have 8, 9, 10, but we can extend that line. We can always find out how many miles is driven in 8, 9, 10 hours just by looking at the graph. Here, let's see, 5, 10, 15, 20, 25, 30, 35, 35 by 5. That's 5. That's 10. That's 15. That's 20. 25. Here, 30, 35. I'm going to continue. 40, 45. I'm going to go all the way to 50. All right, so what do we have? 3 miles, 15. 3 hours, 15. 4 hours is 20, yeah. So you can tell. It's going to go up like this. And on the test, you're going to get a ruler, and you're going to start a line. This one starts at 0, 0, okay? Extend that all the way out to a straight line. That's our line. And then, notice that even though 8, 9, 10 was not part of our table, I can use the table and now find how far he drove in 10 hours. In 10 hours, you can tell it's 50. 9 hours, 45, and 8 hours is 40. Okay? Let's say we're listening to this today. And that might be your word for the test. There's one more. But table shows relationship. Okay, so complete the sentence. So we're going to talk about hours and money earned. So the money earned depends on the hours, or does the hours depend on the money earned? So I think the money earned depends on the hours that you work, right? So the equation, you can use straight up from the sentence. Use that sentence to your advantage. So M for money equals depends on the hours. Okay, but it's the hours times something, right? How did the 5 become 30? Times 6 times 6 times 6 is 6 to 6. So every value of h here is being multiplied times 6. There's 6 times h. Okay. So independent goes here. Dependent goes there. Let's see where we're going. Let's label this. This is hours. And this is money. Can I do this on previous one? Doesn't work. Okay, I can't. So 5, 10 hours is going to be 5, 10, 15, 20, 25. Anyway, 5, 10, 15, 20. You know what? We're going to skip by 2s because we can. 0, 5 hours, 10 hours, 15, 20, 25. Great, it fits. Nice. And then over here, like 30, 60, 90, we can go every $2. You don't have to go every $2, but because you have that room, you know, spread it out. 30, 60, 90, 2 more boxes, 120, and 2 more boxes, 150. Okay, so this one, again, this one will start at 0. Obviously, we'll start at 0, 0, sorry. 5, 10, 6, 15, 90, 20, and 120, and 25, and 150, 25 hours. He earned 150 bucks. Okay, use a ruler. I don't have one. Actually, I could use a. Alright, so, and that's that. Okay. You know what? And that's it. Okay, so wait, actually, you know what? Let me make this magic word list a little bit more challenging. That's that. So, your magic or your points, it's going to be, and I wrote this word over here. Right? That's the singer you can barely hear. So, your 5 point is going to be based on the answer to this question. Who is her? Okay. Thank you.